Hi everyone, a very warm welcome to our talent showcase. I'm Vivian from SG Innovate's talent networking team. I'm your host today for Power Up Robotics and You session. I'd like to tell you more about Power X program and where we develop talent capabilities for the deep tech sector. Kickstarting the first track of Power X program is the robotics track. I believe many of you have an interest in building a career in robotics. There's a high demand for robotics engineers, but not many are trained in the skills that robotics companies are looking for. Power X Robotics is designed to close this competency gap and help build our homegrown timber of robotics talent. Power X trainees will also receive a full sponsorship that includes a 3-month classroom program customized with inputs from robotics experts, followed by a 6-month guidance from a dedicated mentor while applying all the skills on a real project at a partner company. Throughout this 9 months, Power X trainees will also receive up to $4,000 worth of monthly stipend. As each of our partner companies are actively hiring, by being on Power X program, you are already a foot through the door. And you will also be considered for potential placement at the end of the program. Now, here are the partner companies participating in Power X Robotics. And today, you'll be hearing from NDR Medical, Movel AI, Polybee, and Technik about the exciting projects that they do. Now, without further ado, I'd like to introduce our very first speaker for this session, Alan, CEO and co-founder of NDR Medical. Over to you, Alan.
So thank you, everyone. Thanks for coming to this session, and thank you, Vivian, for the introduction. So I'm Alan. I'm the CEO and co-founder of NDR Medical. And as you can see, robotic system, ANT is our flagship signature product of the company. So the vision of the company is actually to harnessing AI and robotics to reinvent minimum invasive surgery, one that is less user-dependent, faster, and safer. And we empower clinicians to perform surgeries with more confidence. And that is the overarching vision of the company. So if you were to join us or if you see us, I think everyone who is with us share the same ideas of how we are going to go to the market with our technology. So just imagine, give you a bit of a futuristic view of it. Just imagine in the future when surgical robots become small and affordable, enough to be found to operate even in outpatient clinics. So no longer are we restricted to being within the operating theater whereby all the most sophisticated equipment are around and you need to be sterile and everything. Just imagine now it's so easy to use that even with outpatient clinics or even smaller hospitals, community hospitals, they can adopt such a system because it's small and affordable. And imagine a time where these robots can be put into auto drive, meaning we no longer require full attention from the clinicians, whereby the surgeons or the clinicians could be focusing on the patients, whereby some automation in terms of the robotics can operate using vision analytics and the precisions from the robotic arms to perform the surgery itself. And overall, we understand that it's going to be much faster and accurate than humans would be. So let me now introduce to you the world's smartest and lightest robotic system, which we term it as NX, which stands for Fluoroscopic Guidance Robotic System. Overall, robotic system that we develop is artificial intelligence and image processing combined for the purpose of automated lesion targeting. So when we mention about lesion, it's just any part of the body or an area within the body is kind of, there's some errors or fault, or how do you call it in the engineering terms, something wrong with that particular area within the body itself. That's why we are targeting it for the purpose of doing a biopsy, taking out the tissue sample, or kind of generating active energy to burn away the tumor within the body, or it could be meant for extracting fluids or injecting of therapeutic solutions to cure the disease state. So overall, you can see image integration, lesion detection, trajectory planning, and of course, robotic surgery. So this combination itself is the backbone of our technology. So let me introduce you to the video right now, which can give a more explicit explanation of what we do.
NDR Medical Technology. Introducing Ant-X, an AI robot with image processing capabilities for automated needle targeting. Ant-X device is small and compatible with all type of C-arm. It uses real-time identification and targeting. High accuracy of Ant-X reduces risk of multiple punctures and potential complications, leading to reduced operating time. Checking for efflux of urine while removing inner cannula sheath from trocar needle. The world's first robotics system with artificial intelligence, AI, and image processing for percutaneous access via automated needle targeting. We will be venturing into relevant interventions in neurology, orthopedics, respiratory and other disease areas. Harnessing AI and robotics to reinvent minimally invasive surgery, Ant-X allows surgeons to perform surgery with confidence. With the increase in accuracy, surgeries can be performed faster, safer, with less complications, bringing about better clinical outcome. NDR Medical Technology.
Our technology. So overall, if I break it down into more details, if you guys would like to know more about what our robotic system does, it is a pure robot or a pure machine. The value proposition of it will not be high. So what we did is actually we extract real-time medical images from the image modality. Then we AI and image processing it. By then, we actually identify three-dimensional coordinates within the body so that we can use a needle, because it's a three-dimensional issue, volumetric, how we can put a tool to right at the target to do whatever I mentioned just now, biopsy, ablation, injection of fluids, or extraction of sample. And of course, the final step will be putting the tool in. So our family product actually started off with Ant-X, which is the fluoroscopic guidance device. So right now we actually have moved on to CT guided system, which is more sophisticated. You can literally see how we move from a semi-automated system to a fully automated system. My apologies, I couldn't show you the real system itself because it's still under development. There's still patents. But if you want to see and you want to know how we progress, please join us. You will definitely get a chance to work on it. So overall, let me summarize why do we want to use robotic system in the surgical space. It's because from the general perspective, it's much easier to train on robot than anticipated. It's really because today when we pass our system to the surgeons, actually within an hour or so, they meddle with it. You realize that, even though we thought that the medical world is quite traditional or quite conventional in the sense of adoption of technology, but more so these days, a lot of clinical advancement in the surgical robotic space actually makes it so much easier for the adoption to happen. And when we develop our robotic system, we have the idea of ease of use in mind. In a sense, with a click of a few buttons, the surgeons will be able to perform the surgery as per expected. So if you were to develop something so cumbersome and so difficult to use, generally the adoption will be expected to be lower than expected. So overall, during surgery, I think for overall during surgery itself, the performance, the precision, the ergonomics, enable more complex procedures. These are the typical benefit of a robotic system throughout. And of course, what patients should look out for by implementing our solution through the doctors, patients should be looking forward to less frequent complication, fewer readmissions, hospital stay, recovery time will be much better as well. Especially so the pain and the scarring will be less because you are doing minimal invasive rather than opening up the patient. So overall, the market size is very interesting because if you talk about the medical world, the AI, machine learning, and the robotics part is the most impactful or the most realistic thing that will come on board the next 2-3 years. So this is a survey done with clinicians, what they believe in, whether you're talking about AR, VR, you're talking about other technologies. But overall, AI, machine learning, combination with a robotic system, that is the most realistic thing. In the next 2-3 years, you will see more and more of such robots coming on board. And NDR, we are really at the early stage of the curve. And you can see the last statement, the US particular expects further enhanced image to come soon. So meaning with better images, we actually can understand the envelope of penetration for our equipment and tools, and there will be better precisions and better outcome for it. So overall, the market size is humongous. This is not a dying industry. This is an upgoing industry. So if you want to join something to grow with or to last you for the next 30 years or 40 years or for life, please join the medical surgical world of robotics. So overall, this is by Essential. They mentioned that AI elevates burden of clinicians. So you're interested in AI, robotics, a combination of AI is the best value proposition that we can have because of the clinicians supply drop, and there's a strong demand for medical care as we go along. So this is a chart by J&J in 2014. Very interestingly, most of the traditional benefit of our current operation system are, as you can see in the screen, currently all the robotic system, if you're talking about some of the more reputable brands, they are literally talking about the marketability of the system. It becomes, when hospital purchase the equipment, it becomes more branding. Then you literally talk about 3D visualization with the camera, surgeon's comfort. But for NDR, based on this chart, we are already charting the future. We are literally targeting some of the unmet needs. So J&J actually put up the future will be data integration, image integration, reduced footprint because we are one of the smallest robotic systems out there in the market, cost reduction, and of course, improved decision making. This has been the combination of AI. So NDR ANT, which is the robot that we developed, is really at the frontier of what we are developing. So you can definitely see a lot more publicity of us coming up. Please look forward to it. So this is also an acknowledgement by J&J's CEO that robotic technology are part of the company's transition into digital surgery and will be a critical element to their future success. We have various positions that is opening. So even if you cannot find any positions available within the portal itself, please write in to jobs@ndrmedical.com to check in with us, because there are some positions that we never really announce to the market. But if let's say there's interest and we find that there's a talent need, we can always explore what are the various positions that we can cater for individual, because we don't believe fitting people into the job. We believe creating jobs that is relevant to the individual and grooming them. So going forward, I'm not sure whether this video can play and there's sound, but this is one of the testimonials given by my intern when he became a full-time staff of the company.
Hello, I'm Wei Qing. I'm a mechanical engineer at NDR Medical. NDR has actually a lot of young employees, or at least young at heart. So the company atmosphere is actually quite fun. Even our two bosses are actually really quite young. That I actually always enjoy designing and inventing new things. So actually that's why I actually feel I'm actually good at engineering related things. And second is, I actually always wanted to help people in a medical perspective. A med tech company like NDR is an ideal place for someone with my interests. Actually, when I was an intern, I was always willing to do my best and always improve myself in all aspects. But I feel in NDR it's very important to have a very driven attitude, to have a think out of the box mindset. We actually went to Play Nation at Dhoby Ghaut for company cohesion. So we had fun playing console games like Mario Kart and FIFA. At NDR, we actually get the opportunity to observe surgical procedures. I feel this is not something that if you're not in the medical field, you are not able to see. So from our engineering knowledge, we actually can help to improve these ideas and improve the procedure. To be an employee in NDR, we are actually constantly exposed to many kinds of emerging technologies while we are working on our projects. So NDR is also a very good place to experience product development from ideation to commercialization. So you actually learn the full process. So I feel the learning opportunities at NDR are very valuable and are definitely very useful for anyone's career.
All right. thank you. Thank you for everybody's attention on some of the testimonial given by my intern, now staff within the company itself. Literally, I guess he has been with us for 2 years. So for anyone thinking of joining us, please do consider, really, because if an intern who has spent 6 months with us and in the end decided to join us, I think that's a very good testimonial for the company and how, as founders or as the management, we really take care of our employees. So join us, build the new AI surgeons together with us. Thank you.
Thank you, Alan, for your sharing. Wow, now we all know that surgical robots driven by AI technology can do so much more than what we can actually imagine. And of course, if I need a job for 30 years, I know where to go to. In the meantime, please pose your question here and we'll get to them at the end of the presentation. Should you like to also direct some of your questions to a particular speaker, please also indicate the company's name against the question that you pose. And next in line, we have Abhishek, CEO and co-founder of Movel AI. Abhishek, over to you.
Thanks, Vivian, for the introduction. Thanks for joining in today. I know it's a weekend, and thanks for taking out your time and joining all of us today. So just to give you an introduction about Movel AI, we are a 3.5-year-old startup having funded by HG Innovate, and I'll show you some of our videos. I'll begin with showing some of our videos.
It's a deep tech company providing AI-based navigation software for robots. Our technology helps robots to see and act the same way as humans do, while reducing sensor costs and increasing accuracy. In this section, green dots represent the objects which were there previously, whilst blue dots represent new objects just like this person. From these dots, our system extracts a pattern and defines a shape for each object. Once combined, you can see the robot in action on the left, the camera map in the middle, and the LiDAR map on the right. Initially, the robot avoids the obstacle by moving to the left, but now, when there's a glass wall on the left, it moves to the right as there is no space. The robot stops if the destination is occupied. Here is an example of our customers who have used our solution for robots operating in the wafer industry where the environment is dynamic and accuracy is paramount. We have worked with clients in the hospitality and service industry. In this video, the robot was assigned to go to different rooms to deliver items. The robot is able to dynamically avoid people even if they suddenly jump in front of its path. No matter how rough, dynamically changing, or narrow the path is, our navigation system can navigate any robot, big or small, to the destination. In this video, you can see a series of obstacles and the robot generates a smooth path to avoid them. Our unique sensor fusion algorithm using computer vision and LiDAR allows us to identify different objects. It dynamically switches reliance between different sensors based on the surrounding environment.
Yeah, so that was a quick introduction about our company. As we said, we are a software company providing AI-based navigation solutions to different hardware robotic companies. So why we chose to go into a software industry and not go into hardware? So when we started out this company, we looked at the various navigation systems and the problem faced by a lot of hardware robotic companies. And we felt that they have been using very expensive LiDARs or sensors to begin with. And we thought, like, if we use a more low-cost system to reduce their cost, the robots would be affordable to a lot more people, not just to high-end people. So we thought of, we started replacing the LiDARs. The LiDARs are distance sensors. And we thought of, like, instead of using high-cost LiDARs, if we can optimize the software and use low-cost LiDARs, the system should still work. So yes, if you use only LiDARs, yes, they cannot detect glasses. There are other issues with that. So we use a combination of a camera and a LiDAR to solve the challenge. Now, say suppose if there is, traditionally they were also using line following robots in warehouses. If you use that, and say suppose someone just drops something on that line where the robot is following, the robot will not be able to avoid that obstacle. And if you are using robots to solve any issue, and then you still need human beings to keep going and interrupt to help that robots. I think that something is done. It's not an optimized solution, and that is where we come into picture, where we say that yes, we are providing dynamic solution. It can work in dynamic environment. It can work in outdoors. It can detect glasses. So it can do a lot more things, and we optimize a lot in our software. So because we are using camera, we can even get the shape and size of a human being. So like suppose if someone is walking in front of you, you will know who is walking. So so that you can follow that person if you want to. And the second advantage which we have is that you don't have to do any changes in the environment. You just bring the robot into a new environment, map it once, and it's ready to go. So we have launched, the software is called Sirius. So the advantages of our product is that it can work in very low, in low lighting condition, that even if it is completely dark, the system can work. It can handle glasses. It can do visual detection. It can do a person tracking. It can even detect the danger signs. Then it can do multi-floor mapping, which means that if the robot is operating in a shopping mall, it can take lifts and then store different maps. And also we have a very good user interface for our users to use our software. So because of this, our system becomes very robust, which means that if a robotic company is using our software, they can use these robots in any kind of environment. Secondly, it's very accurate. Like if you need a docking, which means you want the robot to charge and needs to park itself within an accuracy of within 2 centimeters, the robot can do that. Then another thing is that we are doing an onboard computation. Say suppose if the robot is connected to internet or the cloud, and the cloud service breaks and robot encounters an obstacle, the robot will not know what to do if it is connected to cloud. So we have optimized the solution to work it on board. And again, our software is such that it can work in any kind of robots. So it's like even if a robotic company has few different type of robots, it can work. We can work with our software. We don't have to change the software, and it can work with maybe 5, 10, 15. How many robotic companies are there? So in short, any robot which has to go from point A to point B can use a software. So because of this, the application use case becomes very high. So it's like our software can be used in industrial warehouses, can be used in cleaning robots, can be used in security robots, can be used in service hospitality. So, and we do have customers to back us up our claims. So as I said, we can work with robotic companies who have no navigation system, who are using magnetic tapes, who are using LiDAR-based system, who are using camera-based or anything like that. We can work with them. We are currently partnering with a lot of sensor companies so that we tell them that we will use your sensors and they can promote our software to their customers. And also we work with end users because we have a good partnership with our customers where we are selling our software to those hardware companies and to someone, say suppose, give you an example, someone like IMDA, and they have a good use case, or a shopping mall. They said, I just want a robotic solution. We can work with a robotic company and put our software and give a combined solutions to them. So if you are part of our team, you not only get to work on only just one product, you get to work on a lot of different type of robots, a lot of different type of environments, a lot of different type of customers. And as I said, we have worked with robotic companies who have used our system. So some are using it in cleaning robots, some are using it for hospital room service, some are for warehouses, some even for personal mobility devices, in-mall deliveries. With BCA, we are working on an inspection robots. So we are gonna work with a company which is gonna launch a UV robot for disinfectant because of COVID. So this is what I will focus more on. So we earlier this year we were a team of 5, and now we have grown to a team of 14 people, almost 300% increase in this year itself, because robotics is in huge demand, and we are expanding, and we are looking into getting a lot of different type of people who are not only interested in hardware space, but also interested in software, also interested in debugging, also interested in integration. So we have a lot of openings in our company. Please feel free to write to us, and do contact me, or do apply at careers@movel.ai, and we'll get back to you. Yeah, so in our team, like we have people from doing research in PhD. So someone is working on human detection, someone is working on algorithms for environment detection, someone is working on ramp detection, like if the robot has to go into a ramp, someone is working on lift integration. So so you will find an expert in all these fields. So if you join us, not only you will be a part of a big team, but you will get to learn a lot from it. And I think if you notice, that average team size is about the age of the team is about 27-year-old. So which means we have a lot of energetic young fresh graduate coming out of school. So it's not like we are only hiring experience, we are looking for fresh graduates as well. So please feel free to reach out to us, and yeah, reach out to us. Yeah, thanks a lot. If you have questions, please reach out to please type it down, and I'll be able to answer them at the end of the session. Thanks. Over to you, Vivian.
Thank you, Abhishek, for your sharing. I particularly like the little robots that is moving in your video, and also the amazing optimized solution that I see. So now let me introduce the third speaker, Siddharth, CEO and founder of Polybee. Let's find out what Polybee does. Over to you, Siddharth.
Hi, everyone. This is Siddharth, founder and CEO of Polybee. The first solution that we are building is autonomous pollination in indoor farming. But that's really just the beginning. You know, I want to share with you what exactly the company is about, why we're doing what we're doing, and you know, what are we planning to do in the near future as well. So firstly, you know, before I begin, a big shout out to the team at SG Innovate for putting this together, for starting such amazing programs, you know, be it Submission, Infinity, and now Power X. You know, despite of these tough times globally, you know, it's initiatives like these which really support companies like ours and exceptional engineers such as yourselves. So once again, thank you very much to everyone at SGI for putting this together. So let's jump right into it. You know, before I get into the kind of, you know, projects that we do and the kind of solutions that we are building, I really want to spend some time on, you know, on what exactly brings us together as a bunch of people, as a bunch of professionals, and how do we go about picking the problems, and you know, why are we even doing this in the first place, right? So just before we get there, a quick introduction on the company as well. Just trying to get this running. Yeah, okay. So just a quick introduction on the company. We are backed by the Temasek Foundation. We work very closely with the Singapore Food Agency as well, which supports us in our pilot studies. It advises us and also has provided us with sort of infrastructural support in the past. And Polybee is a pretty young company. We are a spin-off from NUS. We went through the NUS Grip Accelerator program in 2019. And right now we are a team of 5, and we have a bunch of interns as well. And we're really looking forward to having more of you on board in the next few months. So that's just a quick introduction on the company, who our partners are. And now I want to talk about, you know, what exactly that we're doing and why we're doing it in the first place. So you know, Polybee is it's a mission-driven company, and the mission that we are on now is to enhance food security. And that's simply because it's one of the most important problems of our times. And if you look at sort of, you know, the way we have been growing our food, it's quite alarming. And just, you know, a few decades down the line, let's say by the year 2050, if we have to feed the world population, which is going to be nearly 9 to 10 billion, you know, we need to produce 70% more food than what we do today. And that's a staggering number, you know, especially keeping in mind the fact that arable land is only depleting, fresh water is depleting. So the walls are kind of closing in, and we really need to come up with ways to grow faster, better, and more efficiently. And that's exactly why, the problem of food security is so critical and something that we are striving for, right? So that's the reason why we're here. That's the reason why Polybee is, is a company building these particular solutions. And that's what we also want, anyone who's potentially joined the company to know very deeply and also deeply care about as a problem. And that's basically at the core of what we do. So, this is a fuzzy mission, right? I mean, let's say if you want to solve food security, there's not one person or a company that can do it. So we need to really, move from that fuzzy sort of problem area to more clearly defined problems. And what we did for that is, we sort of looked at the entire value chain of how food supply chains work, and we studied it from a systems point of view, right? And what we realized is, that it's a very so food security is like an umbrella problem, right? There's so many details. There's so many. It's a complex web of a bunch of nodes, and at a high level, you can probably classify problems in food security along a few nodes, and these nodes are starting from agricultural inputs, what kind of chemicals and that we're producing, what kind of seeds we are producing for farmers. Then it's production, which basically includes largely all the farming community, which is really massive globally. Then after production, there's distribution. How well are we able to distribute food? Because in a lot of cases, the problem is actually not the volumes of production, but it's how well we're distributing. Are we doing it in a timely fashion? Are we wasting, along the way as well? So that's how one could go about breaking down the problems in food security. And then we investigated, and then we realized that, as a team, what we're best positioned to work on is a bit upstream, in production part of things, wherein, we have capabilities in robotics and engineering and vision, and we could find out problems, in that space, which we could work on right off the bat. So that's why, we realized that, okay, if our mission is enhancing food security, the means to achieve that mission should be trying to work on problems in productivity, which is further upstream. And as a result of that, we then looked at, all the areas, of agricultural production. And here's where things get interesting, right? If you look at the entire spectrum of agricultural production, nearly, a third of it is actually dependent on the process of pollination, right? And when I say that, I specifically mean pollination, which is enhanced, or rather, in fact, not even enhanced, almost dependent on natural pollinators, right? So, I'm largely talking about horticultural crops, right? Fruits, vegetables, and actually to some extent staple crops as well, but they're usually not as big of a problem for pollination. But largely speaking, for most part of the food that we eat today, which is largely fruits and vegetables, they're highly dependent on natural pollinators. And the core issue is that, we've left this process to chance. Because, in theory, you could actually grow a lot more from the fields that we have today, only if you could have better pollination. But that's not exactly happening, because it's, as a process, we've really left it to chance. Let me illustrate this with an example, right? Let's talk about avocados, something that all of us love. And if you look at the fruit and its production, right, it's crazy how it's done, because, for example, every avocado orchard, a tree, has a bunch of trees. Every tree has about 1 million flowers every year, out of which only 300 end up bearing fruit. Right. And so the odds of pollination are 0.03%. And the reason why this happens is that avocado trees have, flowers that are gender fluid. They change their sex with time. And there's a very narrow window of 1 to 2 hours in a day where we are banking on bees to pollinate for us. Right. So that's crazy. I mean, that's just an example of how pollination is such an unlikely event at times. And that is what we're really vouching for to get the kind of products that we need. And this is just one example. There's so many other crops all over in all sectors which suffer from poor pollination. But what we're really particularly interested in, first up to begin with, is a particular sector, which is, a class of crops, which is largely grown in indoor farming. And the reason is that, a large part of production is, if you look at indoor farming production, is actually for fruit and vegetable crops. Because, if there's anything that you can grow in indoor farming, is these kind of vegetables, such as tomatoes, berry crops, bell pepper, and let's say eggplants and so on. And it's kind of, also very relevant in these times to grow indoors, right? Because we've seen, problems in production and supply chain, which have highlighted throughout this pandemic, right? It's very imperative for us to bring production closer to cities. That's exactly where a lot of people, will be living in the next few decades, right? So that's an important, sector that we should look at, where pollination is a problem. And it's also the other reason why indoor farming is really critical is, the fact that it's an opportunity for us to produce a lot more from lesser land, right? And that's so important for food security, like I mentioned initially. We need to work on productivity, and this is what allows us to do that. And that's because we're getting a lot more control on the growing process, right? We can control the climate, we can control all the conditions that are best for growing crops. And that is what leads to, improvements in productivity by orders of magnitude. So that's why this is such a strategic area and the one that we're working with first. The interesting thing about growing these sort of crops which are pollination dependent in indoor farming is that they need pollination, right? For example, tomatoes, berry crops, pepper, and so on. But it's not so easy to use bees indoors, right? Now, if you're, let's say, a high-tech greenhouse in the Netherlands, there's easy access to bees. Maybe you could use them in a greenhouse. But that's not true for majority of the urban areas in the world. Right. So and there's many more countries where, you do not even have bumblebees in the first place. So it's entirely dependent on manual labor, which is crazy, right? It's just not something that we're good at, just not something that we are going to get better at either. So we have to look at the problem in a way that's, not done by humans in the first place. And that's exactly where automation comes in. The other aspect is that, if you look at the other part of indoor farming, which is vertical farms, it's very tricky to use bees indoors because bees need UV spectrum for navigation, which is absent in artificial lighting. And as a result of that, even if you had availability to bees, you can't really, use them efficiently. So that's how we've really trickled down, from our mission statement of enhancing food security to identifying areas which are, most urgent in terms of, the need to increase productivity, and then finding out those sectors where pollination is actually being done manually entirely. And that's how we've cascaded our way, and that's how we've gone about picking up problem, right? So now talking about our thesis and our solution to solve this problem. Our thesis is that to solve for pollination, we need certain capabilities. One is having a fully autonomous platform because we want to eliminate labor, right? So that's absolutely an essential aspect. Second is we need to be able to have a platform which has very high throughput, right? Because there are going to be hundreds and thousands of flowers in any facility, be it a greenhouse, be it an indoor farm. And as a result of that, our platform has to be capable of, catering all of these flowers, in a very short period of time. And the last aspect is, the timing of pollination is very critical because every flower has a narrow window of 1 to 3 days where it has to be pollinated. So your autonomous platform should be able to cater that kind of throughput, in a narrow time frame. So, based on all of these essential characteristics that we need from our solution, we looked at all the autonomous platforms that are available to us. And one that made economic sense at scale was drones. That's how we actually, arrived at the decision, of using drones, because as a team, as in terms of capabilities, our team is as well equipped to build, autonomous ground vehicles with robotic arms or even drones for that matter. But there's very specific reasons why we're doing this. The other aspect of our solution is precision pollination, right? Because often one of the reasons why productivity suffers in agricultural production of fruit and vegetables is that, there's many flowers, but not all of them are getting pollinated well enough, right? And that can be only addressed if we are catering every single flower on a one-by-one basis. So we're building drones, which are capable of sub-centimeter accuracy so far in indoor environments. We're using computer vision that can make us capable of addressing flowers on a one-by-one basis. The kind of shape that the solution will take is through the form of a service. So you can think of us as the AWS of pollination, wherein all things relevant to it are taken care of, by a system. And the reason why we're going for a services model is twofold. One is to easier adoption for our customers because there will be capex involved initially, and we don't want that to be a hurdle. And second is that pollination is a very complex problem, and we need to iterate a lot to get to make it optimal. And if we offer a service that allows us to participate in that process of iterations, and as a result of that, we can really improve the performance going forward every season. So that's just to share a lot more about our thesis, why we are building this particular solution, and what kind of shape it will take in the near future. So now what I'm trying to do here is to map out the problem statement that our customers have to technical problem statements that our engineering team works on a day-to-day basis. And this is exactly the kind of areas where you can see if this is interesting to you and if you have skills and sort of background experience in. So like I said, right, one of the key capabilities that we're building is precision pollination, which means being able to cater flowers on a one-by-one basis. And that sort of requires a certain skill set in robotics, which is state estimation and control systems. They kind of go in hand. You need one to execute the other well. So that's one pillar. The second is automation of flight in complex environments. Okay, I guess it looks like I got some bonus time for myself. Thank you so much for that. Just to wrap that up, and then the last aspect of that is crop analytics, because with pollination, it just allows us to take more control on the process of production, and we can find out a lot of things about yields and the health of the crop with the platform of drones that we have. And we're having some, we're solving some problems along those lines as well, using tools in deep learning and multispectral image processing as well. So essentially, that's just to give you an idea of what kind of skill set that we're looking for and how does that map to the business problems that we're trying to solve. We are recruiting through multiple channels, with SGI. We are having a couple of projects in submission. One is along the lines of automation of flight and precision pollination, and the other is crop analytics. So there's 2 projects in submission, 2 interns for each. We're getting 1 candidate from Power X, but I can assure you that this candidate will be highly likely to join our team full time after that. And then we're also hiring through the Infinity program, wherein you'll get a chance to build a software infrastructure to deploy all of this, all of these autonomous solutions at scale. So that's just a summary of what kind of roles we're looking for right now at this moment. But please also take note that it's very flexible. Once you jump into one of these problems, you'll have ample opportunity to explore the others as well. So we're one of the things that we're really keen on when it comes to having new people on board is to look for their curiosity and their ambition, because I think those are the 2 core tenets that really unite us together as a team. It's something that all of us share, and also, of course, given this, you tend to also have the ability of learning really fast, because a lot of times curiosity is that driving force for you to learn fast. So if you really identify with these kind of sort of traits, and if you think these are the kind of projects that you'd like to get your hands dirty with, please reach out. We have an exhibition booth here virtually, and I'd strongly encourage you to also go through our culture deck. Like I said, Polybee is also a highly culture-driven company, and I'd love for you to go through it if these kind of projects are interesting to you, and if it really resonates with you, then there's a very good chance that we might be able to work together. So with that, thanks a lot. I'll wrap it up here, and sorry for overrunning a little bit, but hope you enjoyed this. Thank you.
Thank you, Siddharth, for your sharing. It is really amazing how Polybee actually uses mini drones for pollination. And I think there's 6 different attractive roles across 3 different programs. So do check it out at their booth if you are interested to apply. Last but not least, let us also hear from Sumanth, Business Head of Healthcare Robotics of Hope Technik. Please welcome Sumanth.
Thanks, Vivian, and thanks to the entire SG team for setting this up. I think it's brilliant. Even as someone from the robotics community, I feel like we have gone through the journey now in the last 45 minutes of learning about surgical robotics, precision robotics being used, very cutting edge technology through Alan. And then we talked a little bit through Movel about AI being used to scale and enable robots to perform better, to Siddharth's very impressive pitch on what Polybee is doing with automating pollination through robotics. So I think it's a very nice segue into our presentation from Hope Technik today. So just a very quick bit of a background. So I head the healthcare robotics products and services business at Hope Technik. So I'll explain in a little while what that role means. But I think in short, what we're doing is we are solving some very exciting problems using robotics in healthcare at the moment. Healthcare, why healthcare? Because I think one of the opportunities we recognized early on was that healthcare was a field that was beginning to adopt robots in the form that other industries perhaps are not doing yet. So later when I explain a little more about our project and the type of problems we are solving, it'll make a bit more sense. So let me quickly try. Sorry, just give me a second to switch my slide. Okay, a bit of background about the company. I think some of you may have heard about Hope Technik. I often call Hope Technik one of Singapore's best kept secrets. You know, if you're in engineering, you may have heard about it. If not, you probably may not have heard about it, but it's very likely you have seen things that we have built. We started off in 2006, a bunch of 4 co-founders, all from NUS, race car engineers, engineering enthusiasts, basically with the mindset of building new things, building exciting things, and that I think that create a difference that very much aligned with the theme that the other speakers spoke about today. So that's how we started. And since then, I think we've evolved to become a pretty formidable force. So I can just give you through this slide a very quick overview of us as a company. So we are about 120 people. We have our own dedicated factory and facility in the west of Singapore in Penjuru. Our expertise itself encompasses multiple fields of engineering. So when we started off in 2006, we obviously the focus was a bit more on mechanical, electrical engineering, systems integration. But since then, I think the way the industry itself has evolved with the evolution of robotics, with software becoming a very critical component of everything automation related, we have also evolved our own skills and our expertise along the way. The kind of sectors we deal with, again, are very diverse. So I personally am more focused on healthcare, but as a group, we look at everything from aerospace and defense to emergency services to logistics to industrial. I think I can keep going on and on. And as a group, this is how we're organized. So we started off as one company, Hope Technik, and within that, there was a division founded which was focused on autonomous mobile robotics, specifically focused on logistics. Since then, the company has spun off to become Sesto Robotics. So Sesto is our sister company, and they focus on building autonomous robotics technology. So these robots basically are used to transport things within logistics environments and hospitals from point A to point B. So think of them as transporter robots or whatever you call them. I think ultimately the idea is to use autonomous robotics technology to solve a very important logistical problem in several industries. And within Hope Technik, we have 2 other divisions. One is our special vehicle division called Trigen. Trigen builds all sorts of exciting special vehicles. Later, I'll just show you a few examples, some of which you may be familiar with. And then Technik Square is our division, which is more of a bunch of engineering commandos. They do anything and everything. You have an engineering problem, we find a solution for it. It's bespoke engineering services at its best. Trigen Automotive. So this is the first division that I mentioned. I'll quickly rush through this. These are just a few pictures of some sample projects that we have built in the past. So you may have seen the buses flying around Singapore, especially in the times of COVID. So COVID transporters is a thing we work with SMRT to build. It has a negative pressure system inbuilt inside that allows suspected COVID patients to be isolated from people who are normal at the moment. So the entire bus is designed in a very special way. The thing at the bottom is the red rhino, which many of you may have seen on the roads. Anytime there's a fire accident in narrow spaces, the red rhino is deployed in these environments. Then Technik Square, the bespoke projects that I talked about more recently because of COVID, we have been doing a lot of exciting work in certain areas. For example, the first thing you see there is a temperature assessment system. So this system itself is used basically in multiple public facilities, easy to set up system to quickly measure your temperature to a very high degree of accuracy. So that's quite critical, I think, in the current environment. So What you see to the right is a project that we did for one of the universities a long time ago. It was an exoskeleton that is used for patients who have undergone a stroke episode, recovering, and then who need help to rehabilitate. Then a couple of other pictures there. You see a spaceplane demonstrator that we worked with Airbus several years ago. So I think the idea of presenting all these, even though they're not robotics related, is to just show you the sheer diversity of the work that we do at Hope Technik. So coming more specifically into robotics, which is where I'd like to spend a bit more time today. So this is our sister company, Sesto. I've just shown two of our older generation robots. So what you see to the left is the autonomous mobile robot base that Sesto is an OEM of. So we build the entire base from scratch, meaning we are the original equipment manufacturer. And what you see to the right is systems that we integrate on top of it. So the robot to the right is, obviously a very scary looking, not so very exciting looking robot, because it is designed for industrial purposes in a semiconductors facility to transport things. So you see a robotic arm attached to the robotic base, and then that arm is used to pick and place items, and then the robot base transports it from point A to point B. So we've evolved from being a company like this, and I think in general, our robotics deployments, the exciting thing that I find is that we build robots for all sorts of different things, because often these come as bespoke projects. Over time, some of them have evolved to become products. So for example, the firefighting robot that you see to your left, that is something that we did for SCDF. So is the mighty transporter to the right. So these are the type of robots that you don't really need in a very high volume, but they solve very important problems in the emergency services space. What you see in the middle, the one with the shiny lights, that's a UVC sterilization robot. So after COVID, as we're all aware, I think the focus on sterilization and keeping environments clean cannot be undermined, especially in areas like hospitals. So that's a product that Sesto has built. We've begun to deploy it in several facilities now. What you see to the bottom right is an automatic inspection vehicle. So even though it's not a classical robot, it is a solution that falls in that same realm, because it's operating several meters below the ground to monitor our tunnels for faults, which is quite critical. Every time there's potentially an MRT breakdown, you also need to know if there's any structural defects. And that's exactly what this system helps to identify. So this is just to give you a flavor of, I think, the breadth of robotic deployments. Before I delve into this, I just want to give a bit of a context about, I don't have slides for it, but I'll try and summarize it in a minute. So I mentioned earlier about healthcare and why healthcare. In hospitals, you may have actually noticed certain types of robots. If you've visited Tan Tock Seng Hospital, or if you've visited SGH, certain other hospitals, you may have seen large robots which transport food trays, which transport bed linen, and which transport medicines and other things from point A to point B. So as these robots started being adopted by hospitals, what we realized was that multiple robots came with different set of systems. Right, that's problem statement number one. So each OEM comes with a completely different set of software, completely different operating manual. And then you also had the issue of different systems within a hospital environment. So you can have, if you've ever been through, as a patient through the hospital journey, you access your medical records at one place, but you go to your lab, but your lab records are stored in another environment. Then you have your nursing data in another system. So I can keep going on and on. So the short message is that there are multiple data and information silos already existing within a hospital. And then now, if you think of robotics being deployed widely in hospitals for transportation, for cleaning, for all these things, you can just imagine that everything becomes even more siloed, right? So that's precisely the problem that we set out together with the partners on the slide to solve. So about two years ago, we started working with the Center for Healthcare Assistive Robotics Technology in CGH. Then IHIS, of course, from the Ministry of Health Holdings, then Open Robotics, which is sort of the founder of the robot operating system. So a whole bunch of people came together as a consortium, and we said let us try and solve this problem in hospitals first as a proof of concept. And then eventually our goal is to deploy allow hospitals rather to deploy multiple robotic systems within hospitals. And the reason I think as someone from the healthcare world, I feel quite passionately about this because, you have an environment where the nurses today in hospitals, they end up doing a lot of manual work, which technically they're not equipped to do, or, they don't have the physical capacity to, like carrying things, entering a lot of data manually. So much of it has the potential to be automated, both to increase the patient experience, to enhance the patient experience, as well as the experience of the staff themselves. So there's a lot of potential. There's no doubt in my mind that robotics, beyond areas that Alan mentioned, through areas of surgery and precision robotics, you also have a lot of other areas where robotics is here to stay in healthcare, right? And it is solving some very critical problems. But in order to do that, I think a lot of work needs to be done in proving that, these type of systems can interoperate with each other. We can actually create a reliable enough system to make sure that these robots are able to all operate in the same environment. So later, I'll just be showing you a video rather than trying to explain the slide itself on how different types of robotic systems are able to use the lift environments together. Then you can actually deploy robotics to do things which in the past were very manual related. So please bear with me as I just share one video, and I will voice over the video because the video itself doesn't have any audio. So I hope you all can see this. Okay, so I'm just playing the video. So here you can see one of the robots that is used for like you'll actually find two different robotic systems which are being used for separate tasks, very, very reliably cooperating with each other, which in the past would not have been possible. In the past, each robot was actually required to take a different lift. But what you find here is that this first robot, which is like a mail delivery kind of robot, you see it going nicely in, and then it parks itself in a corner. And then this is the second robot. So this system that we have built allows us to have another robot reliably interoperate with this, enter into the same lift. You see, there's a simulation that demonstrates the same thing. So at this point, you can see, the robot has reached its destination and it has exited, right? And then also in a hospital environment, you will find that it's important for different types of infrastructure to give priority. So you see a nurse pushing a hospital bed, but the robots are actually giving way to the nurse because obviously a patient in crisis is more important than a robot transporting things, right? So let's say if there's an emergency situation where, the nurse hits an alarm button and then you actually see the robots making way and parking themselves at designated locations. And why is this important? Because you wouldn't want the robots to block the path for more important things. The final thing I want to show is like a last mile delivery. So you can see a patient using a user interface, trying to order something. You can see a nurse without moving from her nursing console, actually accepting the request, deploying the robot for the delivery. You see a robotic arm picking a beverage, placing it into one of the robots. And the robot itself now makes its way, again, probably through a lift in the door. It finally reaches the patient's bedside. And the patient actually uses an RFID-enabled patient tag to access the drink. So I think at this point, let me just stop sharing. So I think the idea is that we've been trying to demonstrate through our work in R&D, and we are actually moving into production very soon. What I've shown here are snippets and bits and pieces from our demo versions, but then eventually in the next 6 months, what you will see is this system being implemented in various public hospitals in Singapore. So we do hope that this is something that benefits both patients as well as the healthcare professionals alike. So I just have a few more slides. So I think keeping these kind of problem statements in mind. So as you can imagine, we do a lot of work with robotics, but we also do a lot of systems integration work. So we're looking for people. These are a couple of positions. You can actually even go into our virtual booth, speak to Sonia for more details, or get in touch with me later. Happy to share more details. But the kind of people we're looking for, I think Siddharth mentioned earlier, very similar. We want people who are very passionate about the cause. Like, your skills are being used to solve important problems, and we really want people with that mindset and attitude. Of course, you need to have some very strong fundamentals in the scripting languages commonly used in robotics. And if you've had some exposure to robotics in the past, then that's even better. So just a quick snapshot of our people. So these are our 4 co-founders. You can see, obviously, when they were much younger, they still are very young at heart, but just to give you a sense of who we are. This is our lobby. If you ever walk in, we have a rock climbing wall, a slide that is very, very steep and dangerous. We have all sorts of games and fun. It's a very informal culture that we follow. We organize a lot of social events. I think, especially recently with everybody working from home, I think it was important to bond virtually. So we did a lot of that. So we had our 14th anniversary recently, and then we do celebrate all the festivals together. Anything food related, we're always up for it. So that's it. So, and then we also do other fun family events. So it's a great place. I think I'd just like to wind up by saying that, we have a very diverse culture. I think ultimately engineers, some of them non-engineers, trying to solve problems. We all believe in the common mission that we can use robotics and automation to solve important problems. And if this excites you, please do get in touch with us. Always happy to, to hear your story. With that, I hand over to Vivian.
Thank you for the wonderful sharing from Hope Technik. I'm really fascinated by how the robots is able to recognize each other in the lift and also playing a part in the hospital. In the meantime, if you have not posed your questions in our Q&A chat window, please do so now. We will try to take as many questions as possible by end of the session. Now, let me share with you more information on the program before we proceed to our last segment, which is the Q&A session. Our application is now open to 4th of October, and shortlisted candidates will be invited to an interview within a month. Successful candidates offered for the program will start their structured training in November this year. So should you have any questions that you would like us to address, feel free to post your questions now, or you may just drop us a line at the email shown on screen. For more information of Power X program, do visit us at our Power X website shown on the screen as well. Okay, now let me introduce my dear colleague Sarah Cheng from the Talent Networking team. Sarah and I are working together on Power X Robotics program. I shall hand over the Q&A session to Sarah, and over to you, Sarah.
Thank you, Vivian. I was really intrigued by the company sharing, and I hope all of you felt the same. But due to time constraint, we regret that we may not be able to answer all the questions you have posed, but we will prioritize questions related to the partner company so all of you can hear from them directly during this session. If you have questions related to the program that have not been answered at the end of the session, please do visit us at the SG Innovate booth later today, and we'll try to answer all your questions. So now let's take a look at some of the burning questions you have. I think one of the very popular questions was, what are some of the qualities that the companies look for in a potential employee or trainee? So I think this is relevant to all the partner companies. So maybe I can go by the sequence of speaking, starting from Alan, then Abhishek, Siddharth, and Sumanth. Maybe share what are the must-have criteria or qualities of these trainees you're looking for.
Thank you for that. In actual fact, I think experience and academic qualification definitely matters a lot. But in terms of characteristic of individual, we're actually looking for individual that is very motivated, because we are a pretty small company right now. We are about we're growing up to 20 this year. Overall, I think taking initiative, solving the problems is essential. These are some of the qualities that we're actually looking out for individual candidates. Because as we go along, as we grow rapidly, there are a lot of things that is unforeseeable because we are really breaking new grounds. We are disrupting the technology, and that's what deep tech is all about. And I think we require individuals to put in their effort to find the best solutions available at the point of time. If not, then we will R&D, we will look for the best solution together as a team. I mean, let me quote, you will never work alone. We are a team together, but you need to take the initiative. You need to be motivated to be part of us. Thank you.
I see you're a Liverpool fan. Okay, maybe Abhishek, can you take on this question?
For us, I think problem solving. I agree with Ellen that problem solving skills is the most important thing which we are looking for, because when we are working on new tech or something which has not been done before and something cutting edge, we would encounter a lot of problems. So they should have a good problem solving skills. Like even if you go to a customer side, they should be able to solve that. And that's the most important thing which we are looking at. Secondly, of course, programming background, because being a software company, we are looking for people with programming background, not necessarily robotics experience. I think that we have good team members to train you guys on that. And I think now we have Power X, where you can get trained with using that. But good problem solving skills and I would say programming skills. Thirdly, team player, because there would be a lot of people who would be working on projects together. So you should be able to work together in a team. So these three are the main things which we look in a candidate.
Okay, thank you. How about Siddharth?
Yeah, I think there's a few things that we look at. I briefly touched upon it in the presentation, but maybe I can just talk about the ones which are sort of non-negotiables. Definitely, probably everyone shares this with me. Is that you have to have a strong core in programming, largely in the languages that are relevant in robotics, that is C++, Python, and some familiarity with tools like ROS and so on. But that's all something that we're aware of. I think the other aspect is more fuzzy and something which we spend a lot of time on when it comes to screening is the kind of traits that you have for the kind of work that you're trying looking for. And these traits are largely, like I said, curiosity and the ability to learn fast. It's kind of they go hand in hand very often, and it's something that we've seen can completely change the trajectory of someone's way of working and solving problems. If that's at the core, the details of the problem don't really matter. You're pretty sure you're going to get around, it eventually. So that's how we look at it. And based on that, there's a list of other things that we often share with our new candidates, and that's through the form of a culture deck, which is actually a part of our exhibition booth. So if there's anyone interested in joining Polybee, they should definitely go visit the booth and check out a culture deck. And I think if you just read it out and if you feel that this really resonates with who you are as a person, then you're highly likely a great culture fit for us. Then it's just about evaluating for your technical skills. And with the kind of talent that we have in Singapore, I don't think there's a lot of dearth of technical talent. But what's really important for every single company is finding that culture fit, which is very different, and it kind of also something that changes. So I would put it that way: a little bit of I'd say a specific list of things that we need technically, and then culturally as well, depending on the company.
That's great. Sumanth, do you agree?
Yes, I think everyone has said pretty much all the things, but I think to summarize from our side, technical analytical competency is obviously the baseline. I think robotics and deep tech is a complex area to be in, so I think that's a given. But beyond that, I think what I personally believe in also is the ability to look at the big picture. So always understand every small task adds up in some way to achieving another task, which in addition adds up to something bigger. So I think never losing sight of that big picture, like regardless of whether you're an intern or the CEO or anybody else in between. I think that's the mindset that we look for in everybody. So beyond that, I agree with everything else that the other speakers shared.
Okay. Alan, you mentioned you want to add on to your point?
Yeah, definitely. I want to add on to my point. So I think SG Innovate actually came up with a very good program, the Robotic X. So if you have very experienced, you have all the qualification that we are required for, join us full time. But the whole idea about this program is that, if you are thinking, you're considering whether do you fit the job, feel free to just apply. And because it's a program and is from the company itself, we have to train you up and getting you familiarized with the industry itself and see whether there's a product fit, or there's a talent fit within the company itself. So feel free, if you are unsure, just sign up and join us. We will do the evaluation and we can look at different aspects of individuals' capability and talent. Thank you.
Thanks, Alan. You stole the words from my mouth. I was about to say, if in terms of technical expertise, if you don't have it, then Power X is the program for you. And as long as you meet culturally what the companies have mentioned. So the next question is, what are some of the challenges you face when building your robot? I believe it's another question that is particularly relevant to all the companies. So maybe we can go through the same sequence as well. Alan, please.
The most difficult part about developing the technology or the robotic system is where to start. Once you start, from an engineering mindset, you will always try to optimize the system. You developed it, you go to the field, you go to your clinicians for our aspect, because it's surgical robot. You test it out. If let's say there's any feedback, we immediately go back and revamp to the requirement and we test it again. So the robot, as of today, once we are prepared to launch it, it's actually gone through almost more than 60 plus iteration before we come to this stage, because there's just so much that you are not familiar with. Because if you're developing a Me Too product or something that's already mass market in the industry, there's a benchmark that you are setting up on. But if you are developing deep tech or like breaking new grounds, it's only through this R&D optimization process that eventually we can go to the market. So I think perseverance to overcome the difficulty is something that all developers have to have the mindset. Don't be worried, don't be depressed by some of the initial failures or some of the initial mistake that you make. Always look forward to the better outcome, because programs, robot system will only improve as we push the boundaries of technology.
I see the never say die spirit. Abhishek, do you agree with that? So what are some of the challenges you face and whether that perseverance actually brought you through?
I think I'll completely agree with Ellen, because they being in hardware domain, I do understand that we have to go through a lot of iterations, even for software itself. Like, do we need these features? Will customers need this feature or not? Yes, it may sound good, but will it be a good feature for customers or not? So these all kind of challenges are there. And being a startup, the biggest challenge which you face is because your resources are so limited. You have to make sure that the things which you are working on are being implemented, or there are customers to use those things. So I think the challenge over here is more on optimizing the resources which we have and use it so that, so I'll give you a scenario that you have a customer who is saying that, yes, develop this and we'll give you money. And then you have to do a research also, which might help you in future. So that kind of challenges are always there. And then at that moment, we have to take a decision that if we put our resources into working on for this particular customer, we might have to put off the R&D a bit later. So it depends on what kind of features we are working on. So these kind of challenges are being addressed. And I think it's the team which comes through, we have come through all these things now, and then we have a more stable product. But I think that shows the team spirit as well in a way. So I think even though there were a lot of challenges, but the team stick together to do those things.
Cool. Siddharth and Suman? Maybe Siddharth first?
Yeah, sure. So I think one area of problems which is particularly challenging and because of that exciting is productizing what we're building, right? So I think with a bunch of talented engineers, it's easy enough to build a prototype in a short time, but the real battle begins only when you have to turn it from 1 to n, right? So for instance, for us, just to paint a picture, what we need to get done is have hundreds of drones flying, let's say in a greenhouse or a vertical farm, pollinating effectively and actually making sure that the yields are increasing, the cost is actually lesser than what it used to be. And to get to that level of performance, it's in a lot of ways you have to work your way backwards, right? So for instance, we have to make sure that the unit economics is going to work at that scale, and that governs your technical strategy as well. So for example, let's say if you have to pollinate something like a greenhouse or vertical farm, and if it takes us like, let's say 100 drones, and we then find out, okay, there's no way we can spend as much money on capital expenditure. We need to make our tech better. We need to minimize how many drones platforms we need in the first place. And that means, we need to work better on our sensing technology. That means we need to work better on our ground station and its ability to process for so many drones and so on, right? So I think that's the kind of iterative loop, which is super challenging because unless you've actually deployed, you're not going to find out what's working. And it's the classic chicken and egg problem. So I think, the most interesting and challenging problems are in the process of turning a solution from 1 to n.
Thanks, Siddharth. I think for Sumanth's case, Hope Technik has quite a number of robots. So maybe you can share a common challenge that has been faced when building all the robots.
So I think for those, a lot of I think the challenges are similar to what the other speakers shared. But I think maybe one thing I'd like to highlight, regardless of whether it's software or hardware in robotics, the hardest thing is to build something that customers truly need, not want, because you can want a lot of things. And more importantly, are willing to pay for. Because a lot of people, trust me, have no idea. So I think the market itself is evolving commercially. Even if you take in the history of robotics, the more popular robotics that customers, consumers, normal people like you and me would know of, like the Roomba or other things, they have an entire history and journey of over a decade before they actually came to market, became successful products. So I think that's why I say always that you should have that big picture in mind. But the hardest thing is productizing, making very tough decisions on what features to include, exclude, which are both commercially viable, not losing the utility value to customers. So I think that trade-off is an everyday battle.
That's great. That's great to know. But I also understand that all the companies are persevering very well and overcoming those challenges. The next question, it says, hi, I am a mechanical engineer undergrad and my university curriculum does not cover ROS. And I do intend to pick it up on my own in the future. However, just wondering if I can still apply for robotics roles without knowledge of ROS. So before I pass on the time to the partner companies, I think this is also one of the reasons we have included ROS in our Power X program, because when we spoke to all these companies, they mentioned ROS as a necessity. But I understand that this person would like to pick it up on his own as well. So that's a commendable effort. So maybe for the companies, can you share whether you will be able to consider someone full-time on a robotics role without knowledge of ROS? We're starting from Alan as well.
Thank you for the time. I hope everybody can hear me well. ROS is important, but it's not the determining factor. You can always pick up a new language because languages comes out pretty frequently these days. There will always be a new language once in a while. I mean, ROS to me is a very high-level languages. And when we first started off with R&D, ROS is not the language that we use. So long as you have basic programming knowledge or you have been working on programming stuff, I think we still will be able to consider the candidate. So it all depends on how fast and how much you are willing to learn. It's very encouraging to hear that there are candidates are willing to kind of self-learn even before joining the company. I think that is what we are actually looking for. So long story short, so long as individual is willing to learn, it's not 100% necessary that we require them to have 10 years of experience in ROS. So long as you have basic understanding of programming, I think we could explore that candidate. Thank you.
Okay, sure. I think for Abhishek's case, you've shared before that Movel AI uses a lot of ROS. What's your view on this?
Yeah, I mean, for us, ROS is very important, but I'll give you an example like this. Earlier this year, for our summer internship, we hired few candidates who had no experience on ROS, just because their programming skills were pretty good. And when we gave them a challenge, they solved those challenges without using the traditional methods of ROS. So it shows us that they are thinking differently. So it's not like we always want to have people who have knowledge of ROS, but if you are thinking differently and still able to solve those challenges, I think will be good to have you guys on our team.
That's great to know. How about Siddharth?
Yeah, I think I kind of agree with what just Abhishek said, that if you have a strong programming core, it should not be too difficult to pick up ROS as a tool. And I think what's also the other important point is to just see it as as a tool for middleware, as to how your subsystems in your robotic, platform communicate with each other. So that's one major reason why we use ROS. So one should look at it that way, that it's a tool for middleware and communication between different subsystems. As long as you're aware of that and you have a good programming core, it should not be a big problem at all to pick it up. And the other aspect is that there's a bunch of simulation tools within ROS. I'm not sure how many of the other companies are using them heavily, but it's just good to have a heads up on what they are. It's something that you can pick up really fast. So I wouldn't be too alarmed or concerned if you don't have prerequisites and a prior experience in ROS. But as long as there's a programming core which is strong, you should be able to pick it up very fast.
Yeah, so I realized the similarity among all answers was that there has to be a strong programming core, which is also why our Power X Robotics requirement in terms of eligibility is that we require applicants to have strong basic programming skills, because that means you will pick up other programming skills quickly. How about Sumanth? Is strong programming core also important?
Absolutely critical. I think that's part of the reason why you're building software. So that's again one of the core technical skills that we look for. But I think this question I've received in the past, especially, I think I would urge the person, just don't feel bogged down just because you're a mechanical engineering or a chemical engineering student, because I think now we're in the world which is very skills driven and oriented. So a lot of skills can be self-taught and learned. So if you have programming fundamentals that you plan to build over the next X months, and I think my message is a bit more deep, that don't let anybody tell you that like a degree in non-software engineering cannot teach you how to code or get into robotics, because it's not true. I know enough people who are living to do this.
Okay, I know where what kind of career switch I'll be looking for next. Thank you, Sumanth. So I think we only have time for 2 more questions. So maybe I can take the next one. The question is, what skills or modules will be covered during the 3-month training for Power X Robotics program? So I think we mentioned about ROS. So actually we are going to focus on 6 essential skills to be covered during the 3-month formal classroom training. The 6 skills are, please take a paper and pen to write down, Python, C++, ROS, SLAM, machine learning, and computer vision. So we'll be drilling all trainees in these 6 skills during the 3-month training. We will also be having a capstone project during the 3-month training, so that they can use whatever skills they've acquired and put them to good use before they go on 6 months on the job training after. So the last question is, what's the most interesting project that you or your company have worked on so far? Can we start with Alan?
I think every single project is interesting to us. I mean, obviously we didn't start off as medical robotics or engineers. There's no such roles. We are just engineers, and I graduate from mechatronics. So I mean, typically I'm familiar with robotics. So every day in our life, I think it's interesting, because we get really to see operation, we get to see surgeons, we get to see how humans are being operated on in the operating theater. Is really amazing. Other than NX or the N robotic system, in actual fact, throughout our journey, there are many projects that we, short-term projects that we embark on that help us in part of the skills development, talent development, project management skill set. And those are all in the medical space. And those are all very interesting and meaningful, because I really believe in putting our knowledge into areas whereby we can really do good for mankind. At least that's what I truly believe in. And the whole reason why we developed surgical robotics is also because who knows, right? One day we might be the user of our technology. And like I mentioned, it's not just robotics. There are many other applications and devices, projects that we work on. That's all very interesting and very meaningful. That's why we encourage people with that positive and innovative mindset to join us, because if you are creative, this is where you can really kind of explore and do something good, and you can see your product out into the market. Thank you.
Oh, that's great. I cannot imagine being operated on by a robot so soon. Hopefully, touch wood, don't need. How about Abhishek? Maybe no more motherhood statements like all projects are interesting. Maybe choose one most interesting project.
Okay, yeah, I mean, it's difficult to choose one, but I'll try to explain two. The first one is, it was last year we were working with a vendor and they had a robot which were being used in a shopping mall. So the robot was supposed to deliver items to the different shops in the night time, and it has to take lift, it has to go to different shops and then take the goods and then deliver it over there. The challenge over here is that the lights may be off somewhere, the robot would have to go to the basement, the network might not be good, and the robot, and then people would be there. There will be so many people in the shopping mall. So, and I think the turnaround time for us, the vendor gave us was like 2 weeks to complete the whole project. So once the robot was ready, I think our team managed to do it. Like, of course, they sacrificed their weekends and I think some sleep also. Maybe they were sleeping 2 or 3 hours only, but we managed to pull it off. So I think that was one of the challenge which we loved solving. The other challenge which we are solving right now is like during COVID, because we had to go to customer sites to do it. We deployed our system remotely without even going and touching the robot or just going there. We managed to deploy our system on that robot, all by remotely. So that gave us confidence. Yes, being in a software company, we can still expand and work during this time.
Okay, so I guess maybe Siddharth, can you share also one of the most interesting projects you've worked on?
Yeah, sure. So I think it's the one that we're hiring for through Power X as well as Submission. We're now at a point where we're building a fully autonomous robotic platform for pollination in the greenhouse environment, which is a bit more challenging than something like vertical farming environment, because you just have a lot more area to cover and it's not as well controlled an environment. So I think it's the kind of problems that we've dealt with are going to persist, but with a high difficulty level. So I think that's something that we're really excited about, and we'd love for folks to join us and make it even more interesting than it seems. So yeah, looking forward to having more folks working on it.
Thanks, Siddharth. And for Sumanth, you probably have to choose
maybe
one.
I'm a bit biased because I think I'm here to represent the interests of Hope Technik, but also my own team. So I think from my side, the problem statement that we're working on right now, so definitely that's very exciting, being able to interoperate multiple genre OEM robots in the same environment. I think it requires very good fundamentals and creativity in terms of the algorithms you design, systems integration with different types of systems. So definitely that's one. Another one recently non-robotics related, which I thought was very cool, was we were asked to build a system which can decontaminate N95 masks, because there's only a limited supply of masks and you can't keep throwing them away. So we built a drum, a system where you can take your N95 masks, put it there. The system decontaminates it. So that was put together in record time, I think 8 weeks or something like that. So yeah, we do come across, because we're largely a project-based company, we come across many such interesting problem statements.
Okay, thank you guys. We have come to the end of this session and we hope you had an insightful time learning about what amazing things robots can do. If you have more questions that are partner company related, you can proceed on to the booth, or if it's program related, you can proceed to the SG Innovate booth. On the screen now, you will see a pop-up message which links to our feedback form for this session. We will greatly appreciate your honest feedback for this. We understand that some of you have questions on when is our next track for Power X. So in the feedback form, we will actually also want to get your feedback on what are the tracks that you're interested in. So this will be taken into serious consideration for our future tracks as well. So in addition, there will be a scavenger hunt letter reviewed to you once you have completed the feedback form. If you're interested to join our other webinars, the next webinars we have scheduled for you are Introduction to Cybersecurity, What's with the Hype? That's at 2:30 p.m. in Training Room 2. And Startup and Partner Showcase, What's Your Next Move? At 4 p.m. in Auditorium 1. So to join any of these sessions, simply click on the Programs tab on the menu bar above and select the program you wish to join. So have a fruitful day ahead and see you guys in the other sessions. Thank you.